Coal processing. We already had a look at the introduction, but let's quickly revise it again. We said organic rock consists of carbon. Coal is an organic rock that consists of carbon, hydrogen, oxygen, nitrogen, sulfur, and mineral matter, and these components can vary depending on the type of coal. And then we had a brief look at the two types of techniques used to do the mining of the coal, to remove it from the earth crust. It is done by surface mining and then underground mining, and it depends on the overlying rock. Whether it is thin enough, then it can be surface mining. If it is too deep, then surface mining cannot be done, and then it needs to be underground mining. In our picture, you have a schematic way in which I indicate to you the underground mining methods: shaft mining, slope mining, drift mining, and the surface where it's close to the surface: mountaintop, contour, auger or high wall, and area mining. You see a picture of the surface mining and the underground mining. And then you will remember we discussed the fact that South Africa has got lots of coal. There's still enough, according to the way they estimate. We are still going to have enough for the next 200 years. South Africa produces plus minus 170 million tons of coal yearly, of which Eskom is using most, then Sasol and other metallurgical companies, and 40 million is exported. But burning of coal is an environmental issue. It causes acid rain, it causes global warming, and both of these are sensitive, especially these days, you can imagine. So yeah, we have to have a look at, but it is not easy to replace coal in industry. Then when we convert coal into products, there's three main processes used, namely combustion, destructive distillation, and gasification. And before any one of these can be carried out, the coal needs to be cleaned. And then we have coal cleaning plants where they do the crushing, screening, wet and dry concentration, and dewatering of the coal. The wet methods, is actually very good to reduce ash and sulfur content. That is very good for preventing air pollution. With the coarse coal cleaning, it's jigging and dense medium washing that they make use of. That is, the jigging is referring to air blast, where they get rid of rock material. That is with the coal. In fine coal cleaning, we cannot really make use of that because the fine coal, the particles are so small, you are going to have them distributed everywhere. So that's why here they use the wet concentrating table, the dense medium cyclone, and hydrocyclone, and then froth flotation, one of the most important ways of cleaning. But yeah, we have these coal cleaning plants, and from the coal cleaning plant, then the coal is transferred to wherever we do the combustion or the destructive distillation or the gasification. Now, in combustion, we basically have the coal burned and providing energy, and this energy is going to heat boilers that can generate steam under pressure, and the steam causes turbines to rotate, and then we can create electricity. Different types of firing is used for the combustion. Stoker firing is used for bigger lumps of coal. And the stoker firing is referring to the way the fuel, the coal itself, is entered into the oven. You have the underfeed burning, the crossfeed burning, and the overfeed burning. Underfeed, where the coal and the air goes from the same direction. Crossfeed, where the fuel, the coal, is added from the oven door and then the air come across. And overfeed, where the coal is entered and then the air comes from the opposite side. And that gives different ways of in which the firing is taking place. Then we get to pulverized coal firing and cyclone firing, which is even preferred by industries. The reason for that, their inherent flexibility regarding the kind and quality of the coal. These methods can be used for any type. Even a lower quality coal can really have a good combustion by using the pulverized firing method. It's more available, you can change easily. You have extremely high steam generating capacity. And as a chemist, I suppose you can explain to very easily what the reason is for this. Pulverized coal is coal that is very finely divided. Just to give you an idea, it is like, you know, powder in makeup. That is as fine as these coal particles are. So it's a very fine material, and that increases the surface area tremendously, so that you have a very high development of energy, giving you a lot of steam generation. The process is taking place sort of like the stoker firing. The pulverized coal is transported to the burner with the air, but only 20% of the air that's eventually used for the complete combustion. Only 20% of that air is initially entered with the coal. The other balanced part of the air comes from the furnace walls inside during the process. And then we have another way in which this combustion can be done, and that's the fluidized bed combustion, where the fine coal it's a solid material, but it is, by making use of air blast, it is fluidized in a certain sense. So it is acting like a fluid, moving easily around and then burned. And the material in which that's moving with it in this airstream is things like lime and sand and materials like that. Now the lime is then excellent here to inhibit the sulfur release. So fluidized bed, looking at the environment, that should give you the best results because of the sulfur that is not released into the atmosphere. There's the typical layout of the power station. You can see there the coal that is pulverized into very fine particles, heating inside the boiler. From the from the condenser side, you have your water coming, which is then heated, and the heat is transferred here under pressure. There we have our turbine generator that's creating the electricity, and you have electricity transported all over the country. And then your ashes come down. That is now materials that is acting as waste, but it can be used in the making of certain roads and things like that.